So this is problem 25 of chapter 10 of Giancoli 6th edition. So we have a spherical balloon and they give us the radius of this balloon and it's filled with helium, and we want to know how large a cargo, so what is the mass of the cargo that this balloon can lift, assuming that the skin and the structure of the whole balloon, so the mass of this whole balloon is also given to us, and neglect the buoyant force on the cargo volume itself. In other words, assume that the volume of the balloon, the part that has helium, is so big that we don't need to take into account the volume of the cargo. Okay, so what is the idea? We have our balloon, very large amount of helium here, and a little cargo. And we want to know how much we can put in this cargo. We want to know what is the mass of this cargo that this balloon can lift. Okay. With the radius, since the radius is given, we know what is the volume of the balloon, right? The volume is just 4/3 of pi r cubed. It's a sphere. Okay, so we have that volume. And what are the forces involved here? We have the weight of that whole skin and structure of the balloon, so it's the weight of the balloon, so it's m of the balloon g. We will have, once we add the weight of the cargo and what is holding us, the buoyant force. Okay, so to have equilibrium in this scenario, what we have is the buoyant force is equal to the mass of the balloon g, so the weight of the balloon, plus the weight of the cargo g, and don't forget also the weight of helium that we will use. Okay, so we also have to put the mass of helium g. Okay, what is the buoyant force? Is the weight of the fluid that was displaced so that this balloon could be there. Okay, so the buoyant force is the mass of the fluid multiplied by g. What is this fluid here? Well, this fluid is just air. Okay, it's the air around. So I'm going to write this as the density of the fluid, the density of air, and you can just check it on a table, multiplied by the volume of this air that was displaced, and this volume is the same volume of this balloon, which we are assuming is just the volume of helium, multiplied by g. Okay, so this is the mass multiplied by g. Well, you already see that all these g's will cancel. Let me just write it quickly, the whole equation, and let's get rid of these g's. Okay, now the mass of the cargo is what we want to know. Okay, this one is given to us, is the mass of the balloon. How about the mass of helium? Well, that one is not given to us, but we can write this as the density of helium, and this one we know, we can just get it from a table, multiplied by the volume of the balloon, the volume of helium. And the volume we also have, and we computed from this equation. So this we also have. So with this equation now, we can find what we are after, the mass of the cargo.